Okay, this is what it's like to be a radio station engineer. It's Thursday afternoon, evening, about 5:30, and I'm on the way down to the transmitter. My AM station went down. Got a really high common point, which about the same thing as saying we have a high SWR. And it shut down the solid state transmitter, so we put it back on the backup, which is a tube type, which will suffer a little bit more of a load at 500 watts. So here I go. And yes, I'm retired, sort of. Anyway, we'll sort of see if we can document this little thing for y'all, so you know what it's like to walk in my shoes. Okay, well, and just in case you're wondering, the way we can tell where we're at is with this bridge, operating impedance bridge, OIB1. As you can see right now, I'm down about as low on that meter as I can get. Modulation will bump it around 75. J0, which is what we're supposed to be. One other thing about these bridges, see that little knob right there? That little knob cuts in and out a battery that costs $45. Don't leave it on. Just don't leave it on. Anyhow, so there we are. We're fixed. We're going home. And get something to eat. That was fun. Kind of reminded me of the old days where I had to be down here a lot, but that was back when things were, not quite as reliable as they are now. Remember, I've been doing this now for coming on 30 years. A lot of things have changed. So, all right. Yeah, see? Here's my couple of my towers. The other towers. Hey, thanks for watching, and we'll see you again. Don't forget to subscribe and give it a thumbs up if you like it. See you later. Okay, so that didn't work yesterday. We're back out here today. It's Friday. And first thing I got to do is I got to check the dog houses. And this is a dog house. Or a fair facsimile of one. And it holds the networks to match the antennas up. Antenna. $265 feet for my frequency. It's always fun getting in these places because you never know what's living in here, if anything. So you unlock it, take the hasp off, try to open the door, and let any critters out, including cobwebs. And what we're looking for is any burnt components. Ugh. I hate spiders. Okay. I don't see anything in this one right off the bat. That's the matching coil for the lights. To drain the power, make sure that they don't interfere with the tower, and also lightning. Yeah, I don't see anything burn up, blowed up, or dead things inside of the coils. That thing right there, that you pull that button out and it measures the power or voltage at this tower. And that's how you can take your measurements. Has a little feed through that takes a tap off of it and tells you what's going on. But I don't see anything wrong here. On to the next one. Okay, here we are at the next one. This is tower 2. This is my driven tower, which means, wow, it's got all the power on it. All right. Hey, hold on. All right, that was fun. Couldn't get the door open. Sealed shut. And lots of cobwebs. There. That makes it a little bit better. And what do we got? Dirty cobwebs here and there. What am I poking with? A metal stick. Don't do that, okay? Huh. Yeah, well, that's about right. That up there is a matching network for when we go to a single tower, which we'll be doing today. See any critters inside anything? Anything burnt up? Nope, that looks good. On to the next one. As you can see, it's a ways between towers, and it's fun. It's a fair walk. These are the lines going down to each tower. There's two transmission lines. That's those ones in the middle there. The one on the outside here is an AC line. Am I pointing to the right stuff? And the two outside ones, those are sample lines to come back to the sample meter. So now we're at Tower 3. Hang on. Okay, here we are at Tower 3. See if anything jumps out at us. Nope. Cool. Alright. Had a little bit of water in here though. Get rid of some of the... Sorry about the lousy video, but best I can do in this case. No, I do not see anything blatantly wrong in here. This thing, by the way, right here, those are decouplers. You pull those out and open up the line and push them back in like a big old 100 million amp fuse. But there we go. So this one looks okay, except for the floor's all wet. On to number 4. Okay, and here we are at Tower 4. Oh, the door opened. Amazing. Same thing, cobwebs. And nothing's burnt up in here either. And that's about right too. Well, I don't see anything burnt. Yeah, if you look at this, the wires for the lights, which is this, actually goes through the center of the coax the connector, which is just basically a big copper tube. And the copper tube comes out, makes a loop like this. It's called a drip loop. So the water will run off and down. Comes out of the side of the building through that glass
connector shield, and then just this thing just attaches right there to the tower. And that's the tower, and the whole blinking thing sits on that glass insulator. That whole tower sits in that glass insulator. Okay, well, the dog houses look fine, but I did manage to destroy one lock, which I'm going to have to put together. It's a little crooked, so we'll have to put that together or clean it up or something. Rust, had to beat it with a rock and a screwdriver. And I just realized I didn't show you this. See this loop? This big loop here goes all the way to that building over there, comes down here, loops around, and goes back. The reason for that is that that's the sample lines. All the sample lines have to be the same length. So this tower here is 260, well, half of 265, so 130 something, 2.5, closer to the common point, which is in that building over there. And so the best way to do it is just take the sample line out, run it down there, loop it around back, and in it comes. So that would be about halfway to that tower where that loop is. There, now you know. I didn't actually take videos of the rest of this repair, mostly. Just a bunch of pictures. And I'll try to explain them as we go along. Here is the culprit of our problems. This coil is the first thing that the transmitter sees going into the phasor. And if you look at the very bottom of it there, just above the handle, you'll see that there's a set of finger stocks that touch a little round disc. And I was in there trying to turn that coil to make up for the differences that we had caused by putting in a new capacitor the day before. And I noticed that, one, the thing wouldn't turn no matter what I did, and two, as soon as I touched it, it would spark. And so we came to the conclusion that sparking's probably not bad, not a good thing. So we'll go on to the next picture. That coil on the bottom there is another one. It's real close to the one above it. They're all pretty close to each other in this phasor. And it doesn't adjust. It has a tap on it. There's just a piece of braid with a connector in the side of it. And that thing behind it, or just above it there, is a vacuum cap. And those are very hard to find, and they are very expensive, and we treat that one very well. That coil you see on the top there, that is the other adjustment that you have when you're setting the common point. One of them more adjusts the J, and one more adjusts the resistance, but they do work together. That one up there feels good, and it's not sparking, and we had no problems with it, so I think we're going to leave that one alone. Here are a few more of the tapped coils inside of the phasor. They all look good. I can't see any burn spots on them or anything, and since they're actually not roller coils, or at least they don't have the roller part in them, and they're just tapped with the little clamp that goes over the coil itself, they're probably in pretty good shape, and I'm not really going to worry about them. Here we got the coil out and on the bench. We're ready to start working on it, and we have handy a can of spray WD-40, everybody's favorite thing. It does good, but you kind of don't want to leave that stuff on because it does gum up the works. It's better off if you use an oil that's not quite so gummy, but to get the thing running to begin with, we'll use this. Here's the bottom of the plate that the finger stock rubs against, and you can see that it's pretty well arced up. There's some pretty bad spots on it, and I don't think those are going to be able to be cleaned very well. We're going to have to replace that, I believe. I don't have anything to re-silver it anyway, so we'll just end up replacing that one. And here's a picture of the finger stock that was rubbing against that plate. If you look at it real close, you can see there's even a hole in that finger stock where it burnt completely through. Now these things have been in service for years and years and years. So this isn't really all that unexpected. It just happens over time. Not much you can do about it. So we're going to be replacing that. And here's a picture of the inside of one of those coils to show you how that roller works. If you look at it, it just grips along the sides of the actual flat ribbon that the coil's made out of, and basically just shorts it out from there down to ground, down to the end of the coil. But what's left above it is the coil part that you're using, and so you have both ends of the coil, one through that rod and one through the top of the coil itself, connected, so you can just adjust them with a knob on the bottom. Very cool idea, been around forever. Here's a picture of the new finger stock we're going to use. This is off of another whole coil. The coil wasn't the right value, but the finger stock's fine. Needs a little cleanup, but it definitely doesn't have any holes in it. And off of that same coil, this is the bottom plate, or the contact area where that finger stock goes, that we're going to use. Has to come off of there and take it all apart and clean it up. It looks pretty good. It's been used a little bit, but not very much, so we just got to clean that thing up and get it nice and polished and shiny. Here's a picture of the roller that pinches the sides of the coil ribbon, and you can see that it comes apart in 3 or 4 pieces, and it screws together with that nut you can barely see over on the right there. It's supposed to take a little spanner to tighten it down, but we don't have one of those, so we'll just have to be real careful with a couple of pliers or needle. And here's a close-up of it, just so you can see how the thing actually goes together. They're pretty well built, and they're all silver plated too, just to make sure that they keep working through the ages. After a whole bunch of cleaning up and the use of a little bit of conductive grease down there where that rod goes through where it rotates, we've got them pretty cleaned up and ready to go, and we'll put the thing back together again. Here is the finished product, or mostly finished. It's all put back together, and you can see it's really nice and shiny and clean, and should last another 40 or 50 years, I hope. Oh, why not? It did the last time. And here is a picture of the finished product. All nicely cleaned up and shined up and ready to go back into the phasor. You can see at the top there, that's where the input is connected, and at the bottom where that finger stock is where the output is connected. So that's how those things work, and out to the other building and the phasor. Okay, so we took this thing out, now we got to put it back in. We have to make sure that the input, that the phasor is grounded, because there's 1,000 watts flying around this building. outside of it, and those big old antennas pick it up and feed it right back into here. So we'll short this out, sparks and all, and here it is, all rebuilt. And it goes up here. Wow, did we get close on that? Wow, that's beautiful. I'm gonna put a screw in this one just to hold it for me. Okay, a little tight. See, I might have to loosen. Little jump crossways in there. Yeah, that's good. A couple more screws, or bolt and nuts actually. Yeah, I'll tell you, I've been in these when the jumper cables, which is what we use for grounding it, came loose. My arm inside one of these things working on it, and got a fair burn off of it. You just don't want to do that if you can help it, because I'll tell you, those burns take a long time to go away. Alright, there's that. Yeah, we polished this thing up as good as we could. When I get down here, put it back in, I'll put a little video to show you what was wrong. The whole deal was this wouldn't turn. Couldn't turn this at all. And the reason why was because it the roller had shorted or stuck, and it got, yep, still a little bit on there. Ouch. My boss is here to watch me make sure I do it right.
A bit of RF.
Oh, a little bit of RF, not much. These little shorties are nice. Ow, 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 ow. Once you hold on to it, once you get past the initial shock, it's not too bad. All right. So, that thing is back in there, tightened down. Now, I want to show you, right? If I can get this thing to do this, right there. See those little finger stock? That's what was arcing. And they were arced all the way through. There was actually holes in that finger stock down there, right there, where it contacts that plate, and that plate is connected to the center of this coil, well, wherever it's tapped off of, and it comes right down to this handle, right down through there. So that's how it works. Now we're going to have to plug it up and see if it works. That should be fun. Yeah, I'm here. Okay, well, we're ready to turn it on. I'm a watching. Wait a minute, turn it off. Why am I still buzzing? Oh, that transformer buzzes in that relay up there. Okay, we're back. Yeah. Okay, we're on. Let's check for sparks.
Okay,
About 2.48.
good.
Yeah.
Wow, you got that awfully close to where it's supposed to be. Okay, I'm going to turn it a little bit. Make sure we don't have any sparkage.
Sparkies.
Oh, Bill, that's gorgeous.
Trust me, if it wasn't 2 hours worth of work, I'd do the other one.
Yeah, that was almost exactly where it's supposed to be.
Yeah.
All right. Well, you want to come out and tweak on the OIB?
Yeah, I'm trying to think if we ought to do it with the main or the backup.
Does it really matter?
Not really, but I don't like running this backup. I could run the backup at a kilowatt, I suppose.
Yeah, don't push it. All right, so we're good on that.
We found this thing down at the transmitter. Unmarked. All it says is volume and antenna tuning. I have no idea. I'm going to plug it in. Let's watch for the smoke. Where's the on-off switch? Okay, ready? Here we go. Well, that didn't short out anything. No smoke. There's noise. I don't. What was that? The amp works. We're having an argument over this. The only reason I plugged it in is I think it's a weather radio. He thinks it's a CHU, or CHU? Canada?
Canada.
Why would it have five frequencies?
Difference, either CHU or WWV.
Maybe
When I used to
WWV.
plug it in down here, it always used to pick up CHU. I don't even know if CHU's around anymore.
Yes, they are. Okay, well, it doesn't work. Yeah, it was worth a shot. We'll give this a shot and fix it in another video. Looks like fun. Hey, thanks for watching, and if you liked the video, give it a thumbs up, and don't forget to subscribe and hit that bell so you know if I'm making any more videos, which I promise you I will be. Till later.